All right, so today I'm going to show you how to do density problems. The first thing you need to have is your density triangle. So I have already written it down here. We have DMV, and it kind of helps me to remember if I think of the Department of Motor Vehicles. I don't know if that'll help you, but it helps me remember what order they go in. So the first problem on the worksheet that I gave you in class today, that's also attached to this in Google Classroom, reads, what is the density of carbon dioxide gas if 0.196 grams occupies a volume of 100 milliliters? So the important part here is listening to the wording. This is where a lot of people get messed up. They read the numbers and they think they know what they have. So you need to kind of slow down, read the words, and pay attention to make sure what you have. So I like to come over and actually write down what I have. So the first thing that it says I have is grams. Grams means that you have mass. Your mass is 0.196 grams. And then it says it occupies a volume, so you know you have volume. It occupies a volume of 100 milliliters. So looking at this problem, I know I have mass and volume. I'm going to cover up what I do not have, and the triangle shows me how to work the problem. It is mass divided by volume. So 0.196 grams divided by 100 milliliters is equal to 0.00196 grams per milliliter. And that is your density for problem number 1. To make sure when you're working these, you always pay attention to your units. Your units will tell you what you have and where you are going. So I'm going to clean off this board, and then I am going to work out problem number 2 for you as well. Problem number 2 gives you a different type of volume. And because of that, I want to make sure you guys are fully aware of how to work one of those problems out. So problem number 2 on our worksheet says we have a block of wood that is 3 centimeters on each side. So if you have a block of wood that is 3 centimeters on each side, and you can tell if you look at the units as well, so 3 centimeters on each side, if you look at the units, this is not cubed, which means it's not a volume. So we have to find the volume. Well, if it's the same on each side, then you're going to take length times width times height to equal your volume. So 3 times 3 times 3 is actually 27. So this is times 3 centimeters. Trying to fix that. Times 3 centimeters. You wind up with 27, and this is centimeters cubed. That's where the cubed comes from. Now that's a volume. So now we can go back to the problem. So the block of wood that has a volume now we know is 27 centimeters cubed has a mass of 27 grams. Okay, so my mass equals 27 grams. My volume that I figured out over here, it is also 27, but this is cubic centimeters. And then I'm going to look at my density triangle again. So looking at my density triangle, mass divided by volume, because I'm looking for density, I would take 27 divided by 27, grams divided by centimeters cubed, and that would equal 1. So your answer would be 1 gram per centimeter cubed. And that is the answer to number 2 on the worksheet. So this is one of the problems that everybody got wrong on our first test. So make sure you pay special attention to what you're doing and how you're working this out. This happens to be one of the problem areas where I have a lot of people kind of glazing over what the steps are. So I'm going to work out number 3 for you as well. This one is a little bit different in that it uses displacement to find the volume. So for number 3, it says you have a regularly shaped stone that was lowered into a graduated cylinder holding a volume of water equal to 2 milliliters. So I like to draw myself a picture here to kind of relate what I'm working on. So I have a graduated cylinder here, and I'm going to say 2, 4, 6, 8. We're going to say those are my measurements on my graduated cylinder. So reading the question again, it says it began holding a volume to 2 milliliters. So I'm going to shade this part in. So this is where we started at. And then the water rose to a height of 7 milliliters. So if I would count the numbers between there, I would see, so 2, 3, 4, 5, 6, 7. That's 5 milliliters in between. So I know my volume is equal to 5 milliliters. And that is the volume of my stone. And then the question goes on to say, if the mass of the stone was 25 grams, what is the density? So if the mass was 25 grams, we have mass is equal to 25 grams. Volume is equal to 5 milliliters. What is the density? So same process again. So mass divided by volume, because I'm looking for density, right? So if I have mass divided by volume, then we have 25 grams divided by 5 milliliters. That is equal to 5 grams per milliliter. So that is how you would work that question. And the density triangle is extremely helpful because if I was looking for volume, I would cover up volume here, and then you would have mass divided by density equals volume. And if I was looking for mass, because it gave me density and volume, then covering up my mass here, you can see density is multiplied by volume in order to get mass. So that is how your density triangle works. That is how you work a density problem. If you guys still need any help, let me know. I'll be more than happy to help. You can text me through Remind, which the information is on Google Classroom, how to sign up if you haven't already. Or you can email me, and I'll try to answer as quick as I can.